Hi, this is Mike at Gamefromscratch, and welcome back to our ongoing LibGDX tutorial series. Today is probably going to be the last part of Scene2D coverage, but we're going to be looking at probably the most important part, which is the UI component. Reality is the majority of people that are using Scene2D are using it for the UI capabilities. There's a nice little widget library built in. It's built on top of everything we already know, so it uses the same events and layout that we already know from Scene2D, things like actors and stages. Your UI controls are simply actors, so the event system works the same, etc. But it does a lot of the work for you, so it's a very handy little thing to use. You can also mix and match it with a normal scene. I'll show you how a little bit later on in this. So let's jump right in. The first thing we're going to have to do is we're going to create a project. That's why I'm started at the very beginning. Is I'm going to have to generate a font file. And remember in the past we had to use Hero to do this, a built-in tool. I just want to make sure that when you create your project, you have the tools option selected here. Otherwise, you won't be able to do that part. I actually covered it in a previous tutorial on fonts and text. You'd be able to find either on Gamefromscratch or YouTube. So I'm not going to go into detail about how that part worked, but I do need a font. And that's how we're going to go ahead and make it. So just when you go to, if you want these tools to be included, make sure you press tools or it will not be available. So there our project has now been made. Let's go ahead and just load that up. So, and the other part of this is we're actually going to need a skin. A skin is what tells the UI how to look. It's a lot like a CSS file if you're used to HTML programming. It's coloring and styling details for the various controls you use. For each control you use, you need to define a skin. A skin is very similar to Java when you've actually created it. It uses the same dot notation for the most part for resolving things, but it is in JSON format. So we're going to create that as well. Let's jump into our project. And first off, let's create a run configuration. Since we have, we're going to be using Hero as well, let's give our run actually a good name. So let's go ahead and call this run desktop. And I didn't create an Android project, so the working directory is just under core, like so. And our module is desktop, and our main class is desktop launcher. Apply and run that. And there you go. Works just as we expected. Now let's go ahead and run the Hero tool so we can go ahead and, it's probably Hiro actually. Let's go ahead and run that so that we can generate our font. And that's just a matter of running the GDX tools. Again, I covered this elsewhere so you can follow along there. So I'm not going to really explain what I'm doing. And just run it. Like so. And it's going to create its own name. All you need to do is set the module to desktop, like so, and run. Alright, so here's the tool. I'm just going to go ahead and use the default font. This is the font that ships with my laptop. It's Razor's kind of futuristic looking font. It's fine by me. Just go ahead and save that out. As always, I'm running out of my downloads for some reason. And core assets. We will call that font razor.fnt. Obviously, you can call it whatever you want. That one works for me. Alright, so we're done with that. Change our run configuration so I don't make a mistake later. And close that down. So into core, look at our assets, and we now have a font and a PNG file to go with it. Once again, the PNG file is just the text drawn as graphics. And then the font describes the characteristics of said text. Of said graphics, sorry. It maps each one to a letter. The next thing we're going to do is we have to create the UI skin in JSON. You can do this in Java code. We're not going to in this tutorial, but you can build the skin programmatically using Java. I'm going to go ahead and use config scripts, which are JSON based. We'll call it uiskin.json, like so, and we will come back to him later. One thing you might want to do if you're working with an IntelliJ is set it to plain text, because it does not like the formatting that LibGDX chose. You'll get a lot of really weird artifacts as a result. Alright, so let's go now to the code, and I will switch over to presentation so you can give a bit better view of what we're doing. And most of this we don't need. Since we're using Stage, it provides a lot of this for us. We'll want to clear still. That's about it. And let's go ahead and create our class. First thing, we're going to need our stage again. That's like so. And we need to resolve it, and private. We need our skin, like so. Once again, resolve it. Now, in our create, let's load our skin. This just uses the standard libgdx loading stuff. So you pass in the file handle for it, and you get that gdx.files.internal. We've already done this a few hundred times, I think. UI skin.json. So in that line, and then we go ahead and create our stage. I'm just going to use a screen viewport, easiest one, like so. All right. And wire up input so that the stage is handling it, like so. And finally, let's update our stage, so stage.act, and give it the current time elapsed, and stage.draw. All right, so there's our world. It doesn't really particularly do anything. It should just be a black screen. Oh, we have an error. Yeah, it's trying to load the skin. We haven't actually defined it yet. So that comes next. Let's go back to our skin file that we defined, which here, and open that up. Oops. All right, I missed. Full screen's fine though. Okay, so now we need to go ahead and define our JSON. JSON format is it's basically just JavaScript embedded, and normally it's a comma separated list of, it's an array of comma separated values, like there. That's technically valid JSON. But now let's do the first one. I'm going to go ahead and define some stuff that we're not using yet. These are all the different controls we'll ultimately be covering in this particular example. So you use the Java name resolution. So for example, there's our bitmap font. That is the Java class for the bitmap font. And then we set the values. So again, this is this is an embedded array of values that we're about to do. So we want to set the default font, and we are setting the file to razor.fnt. This looks ugly at first. If you use the if you go to the GitHub for LibGDX itself, some of their demos, there's already one of these already made for you. You can start from there and then just customize it as you need to. Or you can start with this one and add things as you need them. But it's not as scary as it looks. All right, so that is, we're creating a bitmap font and we're giving it its default font's values. File value is razor.fnt, like so. Now our next value is going to be com.badlogic.gdx.scenes.ui.text button. And then here's something slightly different. We're setting a property of text button. So instead of the dot in this case, you're using a $sign. But otherwise, it's very similar to the Java system style, like so. And it is being set to, oops, back you go. All right, hey, you did not go back. Back you go. All right, there we go. Default, you'll see there's a way to specify different versions. Default is going to be the label for, well, our default. You'll see that in code for a second. It'll make sense. So on down, so that we're setting the down property of text button styles. We will set it to default round down. And then up, we will set to default round, and font we will set to our default font. So this name here is from the name we just set here. So we basically set the razor.font as the font for our button. All right, that's set. All right, now let's close out our button style. Actually, I already did. Let's get rid of that line then. And then finally, we want to set a window style, and this is going to be for our dialog box. This is again Java notation, JSON. sign. There's complete documentation for this on the LibGDX wiki as well. Well, I wouldn't say complete, but there's more documentation on this. So once again, we're creating a default version. That label could be whatever you want. You could call it Mike. Just later on in code, you're going to access this property via name, so it just has to match. So it does not need to be named default. So we're setting the property title font to, you guessed it, default font. Like so. And I think I have enough brackets. So that's a basic. That's a UI script basic and JSON file for skinning in LibGDX scene. And pretty much for everything you use, so we're using a bitmap font, we're using a button, and we're using a window, you need to define the corresponding skin for it. As I said earlier, though, in the GitHub, the demo, there is a default UI skin. It's a good place to start from, and then you can just customize as you go. So don't let this scare you off. It's not as bad as it looks. All right, so that's our skin, hopefully without errors. Now let's go back to our code. Should now run. Do nothing. All right, why are you giving me an error? Reading file. Alright, I obviously made a typo. The nice thing is, when you do try to run it, and if it's missing a value you need, it will give you this error right away. And then you can just figure out from the missing what you did wrong. So I'm missing the text button style. Most likely it's a typo. com.badlogic.gdx.scenes.ui.text button style. Okay. Give me 1 second. I think I learned something today. There appears to be a two-way relationship between these. So these have to exist for each control, but the corresponding control seems to have to exist in the code. So let's go back to our code, finish it off, and then maybe it'll be happy. So that was... Where was I? Kick back into presentation. Okay, so we have an empty stage. We loaded our skin, we created our stage. Now we need to actually populate our stage with a couple things. First thing we're going to do is we're going to create text button button equals new text button, and we'll call that click me. Pass in the skin, and here's where that label came in important. So that's saying use the default settings in this skin for text button styling. So there we've created our button. Let's size it accordingly. Let's set width 200 pixels and button.set height at 50, like so. And let's go ahead and create a dialog. A dialog is like an alert or a pop-up. Let's resolve it. Or pop-up message box equals new dialog, and we'll give it the text click message, and once again we will pass in our skin. So we'll do something with the button later. So right now let's just add it to the stage. Add button. It's just like adding any other actor. So now when I go ahead and run this, actually once I resolve this error, Oh, duh. Sorry. Add actor. I was being lazy. All right, there we go. Now let's go ahead and run that. And we have this error again. Class not found. Text button text style. UI skin.json. View. Exit. UI skin.json. Okay, 1 second. Oops. Alright. I just missed the name here. So, to give you here, let me just kick up the error. So you'll no doubt do this yourself. Any typos here, this needs to match the corresponding Java class. Unfortunately, if you look here, it's telling me that com.badlogic.gdx.scenes.ui.text button style was not found. And what did I do up here? It should be .scenes.scene2D. So there isn't a two-way dependence. I just wasn't an idiot. So I just kind of got the pathing wrong. Let's see if I did it. No, I did it right here. So I don't know why. I just missed that there. That should now work. Should. Big word. Okay. GDX. com.badlogic.gdx.scenes.scene2D UI.text button style. Alright, what are you getting mad about? Windows stuff. Okay, so that one's resolved now. Now I've made an error in this one. com.badlogic.gdx.scenes.scene2d.ui dot window, not plural. Yeah, so you're going to do this a lot. Sorry about that. I did it obviously there. You need to match exactly to what the Java class is. So when it's doing reflection and looking at the code, it's going, this doesn't exist. So that's basically the error we got. But there you go. Oops. Bring that guy up. There you go. So that is now a UI control in a scene app. It doesn't actually do anything, mind you, but it's a good start. So let's kick on back to our code, and this unfortunately screwed up before, and I have no idea why. I think it's an IntelliJ bug, and hopefully it's not going to do it again. But what I want to do now is make this, when you click this button here, we're going to show our dialog. Simple enough. So let's add a click event handler to our button. This should look very familiar. It's just like what you would do with a sprite. Add listener, and we're going to add a new click listener, like so, and let's declare that. And let's override and implement the clicked event. And the first thing we'll do, just to show you it working, is pass in dialog.show to the stage, like so, and go ahead and run. So now when we click the button, boom, there's our dialog. There's other settings you can set for like the window background, all that. You can set them in the skin, or you could set them programmatically if you wished. So you could have a different color background. You could have window effects, etc. It makes this look a bit more like a dialog, but that actually is the dialog that we're seeing. So you click that, it now shows. Let's wire up a timer so that it stops showing after a certain period of time. And that is done via... All right, why are you not finding Java timer class? Let me I do this by hand. This is the error I got before too. com.badlogic.gdx.utils.timeutils. Oh, that might be why. Why are they different? Okay, I appear to be having a bit of a fight with IntelliJ. I don't specifically know why this isn't working. There's got to be a reason. It worked just fine when I wrote the original code, but it's really insisting that a certain import doesn't exist. So I'm going to just go ahead and manually add it. I'm going to fight with it the entire way. It's going to tell me that it doesn't exist. Hopefully you don't run into this yourself, but I want com.badlogic.gdx.utils.timer. And there's the problem. For some reason, it's saying this is not a valid name, but very much so it is. And then it's going to do the same thing here in that it doesn't know, and I don't know why it's not finding it. So we're just going to schedule this event to happen, and it takes a timer.task as its parameter. go away. I'm really not liking IntelliJ today. And we'll give it a 5-second duration. Like so, and close that off. So next up, here we'll do an override because we're implementing this new timer task, and all we need to do is implement the run function. And all we're going to do is when this timer runs, every 5 seconds, we just call dialog.hide. Okay. I don't know why the IntelliJ assist on that completely crapped the bed, but it did. So this code should in fact run. Let's go ahead. There we go. So there's our button. We click it. There's our dialog. So that was the event handler firing, and there it goes away. So that's how you can use a timer in LibGDX. I'd like to show you that a little bit more, but unfortunately IntelliJ is not cooperating with me that much. So, but there is this global timer available. You can also create your own timers as you need them. They're handy little things for just stuff like this, fire and forget type processes. But that's the very basics of a Scene2D application. So now we've seen a button in practice, and as you saw, the button is just an actor. You add it to the stage just like normal. It handles events like normal. We wired up an event listener to it just like normal. And it handles it just fine. Now let's move on a little bit to formatting. So one of those things is a challenge on all game programming because you're running on multiple applications on multiple devices, and using pixel coordinates is not often ideal. So what you often want to do is lay things out relative to each other. And the nice thing about the scene stuff is there is a table layout, which you can use things just like if you ever worked in HTML5 pre-div formatting. Everything was done in tables. It's a very logical, intuitive way of doing things. So basically, just think of the world as being one big square, and you can say everything in this square is centered, or a line to the left, or a line to the right. And if you need sub-formatting within that, you just create more and more cells within, and then you have your individual. So you could divide it in half, and then that half into a half, and that half into a half, and each one has its own particular format. It's a very easy way to lay things out, and LibGDX provides basically the exact same thing. Now let's strip this down a little bit, and we're going to go with the same basic file. Get rid of this button and dialog and all that stuff for now. Like so. Alright, so we're back to a base class. Alright. And now let's say we were talking about a basic main menu. You wanted to have a new game and quit. We'll just do that with 2 different text buttons. Very simple. But first we need to add a couple of things. First one is our table, like so. That's going to contain our controls. Next we will add a pair of text buttons. We'll call it button. What did I actually call them the other time? Bad naming. Start button and private text button, quit button. Okay, so we now have a table and 2 buttons to put in it. We need to actually create them though. Table couldn't be easier. Table equals new table. So it takes no parameters. Let's dimension our table. So set the width to the screen viewport. Or the stage width. So our table is as wide as our screen, and we will now set the alignment. Nope, just align. Align, and we will set it to align center and align top. So every control added in here will be put into the middle of the screen and start at the top, like so. Now table.set position 0 and gdx.graphics.get height. Again, coordinates are relative to the bottom left corner. So the left-hand side is fine, but we want our table to actually start at the very top of the screen. Give us our nice little UI-esque layout, because laying out from the bottom left doesn't make any sense to me. So that's essentially we're positioning the table at the very top to start. Now let's go ahead and create a couple buttons. They're not going to do anything in this example. You could obviously put whatever logic you want in behind them. Text button and new game. but we do need our skin, like so. And we need, what was it, quit button, new text button, like so, and quiet game. And done. All right, so we now have 2 buttons and a table. Now, we'll just go ahead with that for now. And now the key difference is the add start button, table.add quit button. So you add your buttons to the table, and then you add your table to the stage, like so. And input processor is set. All right, so that should now work. Let's run that. There. So now you have a new game button and a quit button. Now, logically, a lot of times you're not going to obviously want to layer these things all in one row, and that's the catch. This is sort of like, again, back to HTML. If we just did a table and a table row, that's what we have here. But now what we need to do is what we've done is a table and a table data, but what we need to do now effectively is start adding rows to it so that we have on top of each other. Very simple to do. We just kind of come back into our table right here, and in between these calls we just call to table.row. This will insert a row in between, and now when we run that, vertically stacked. Nice. Now, of course, sometimes you're going to actually want to have that laid out a little bit. Like this stuck to the top of the screen thing isn't great. The spacing in between isn't great. It's also very simple to do. Before our table, we will do a table.pad up. We will put a 30 unit padding at the top. And then for each row, actually just the start button. Nice thing is here, they're chainable commands, so I can just sit here after and go dot, which means table.add is actually returning the cell itself, so you can then call on it like this. So what I'm going to do is say, put 30 units below me. So I'm going to now be not at the top, and there's going to be a space in between our 2 buttons. Let's run that. Ta-da! So laying things out in tables is very simple, and you can start adding tables to tables if you need a more elaborate layout system. Nice thing in this system, you start changing resolutions, resize the window, etc., and it stays centered, it stays positioned relative. That's where this stuff gets invaluable. So it's a nice way to work with like proportional resolution as opposed to an absolute resolution. So table layout is a very, very handy way to line your controls up. Now, one final thing we're going to cover here, and this might not be immediately clear, but you can use Scene2D UI over top of a normal, quote-unquote, normal application. So if you're working with a normal sprite batch like you were up till we started working with Scene2D, you can keep working just like that if you want, and have this scene actually layer over top. Here, I'll show you an example of that right now. So we need our sprite batch back, and I guess we'll need a sprite, like so. And let's just add them to our game here. So position doesn't really matter, but I'll just go ahead and equals new sprite batch. So, and sprite equals new sprite. We'll just use the default texture and stretch it up to match the screen resolution. So that's a new texture. That's a gdx.files.internal, and it is badlogic.jpg. Like so. Oh, resolve that. There. Okay. And sprite.set size, and that will be to screen dimension. Like so. Okay. Yep, that should be about it. And last thing we need to do is add it here. So this part is important though. We're going to want the UI from the stage to be drawn over top of the UI of the sprite rendering we're going to do here. So that means we have to call our batch processing first. So just batch.begin, sprite.draw to the batch, batch.end. So again, this is important. If this was not called first, our UI would actually be drawn underneath it. Or more specifically, we would draw our UI and then immediately draw over top of it with our image. So let's go ahead and run this. So there you go. So you can see this is a normal sprite batch rendered game in the background with the UI controls on top. Now there's one other thing you might want to cover before you get through this, and the point of confusion here is I'm clicking here and the control is grabbing the response, but how is it that now I want this to also be aware of what's going on? So I want the UI, I don't want just the stage to handle everything, and that's the problem. Is right here we have this input processor is set as the stage. We don't want that. We want to be able to handle both events in our game and in our UI. So how do you go about dealing with this? Fortunately, it's pretty simple. First off, I guess we're going to need to be an input processor. And all right, IntelliJ, do the work. Boom. All right, so we are now an input processor, and we have this little guy here to change. Instead of setting the stage, I'm not sure if I covered this in a previous tutorial or not, but if I haven't, welcome to this. We use something called an input multiprocessor. Input multiplexer, call it IM, equals new input multiplexer. Actually, I think I can pass in the parameters directly. So we were going to pass in, we want this and our stage. Now, this is key too. Okay. So what we're doing here is we're creating an input multiprocessor, which basically just kind of groups input handlers together. And we're saying, take both of these and treat them as one. However, the order I'm passing these in is the order that events are going to arrive. So that means that your UI components are going to have first crack at dealing with any UI events that come in. Okay, so that makes sense. So if you want whatever controls you want to be basically the topmost or the highest priority for getting input events, because ultimately they can eat an event, which we'll see in a second, they are passed in first to the multiplexer. Coincidentally, you can build the multiplexer over multiple lines using add calls, but here they are together in the constructor. So now that we've created that, instead of passing in the stage, we now pass in the multiplexer, and now both our stage and our game itself, or I guess technically our stage and our application adapter, can handle UI events. Now let's actually show one. And by first thing we need to do then is wire up one of these buttons so that it receives events. So we'll go to the start button. And I think this is the part that it fought with me before, so let's see what it does this time. New click listener, like so. Yeah, okay. I close that off. Now let's get inside here and implement an override. And we just want to do... Alright, you got stupid. New click listener. Oh, my bad. It didn't get stupid. I did. Alright, there. Get inside, do an override. And it's handle clicked event. Like so. All we're going to do is log out that it happened. gdx.app.log clicked. And yes, you did. So, I'll do a quick run here. Now when I click new, you'll see over here, our message is logged out. Okay? And I click, obviously, everywhere else, nothing. Because it's just wired up to that one button. Okay? I think I just missed. And close. Alright. So now what we want to do is show handling in the base class. So what we're going to do is we're going to flip that sprite when it's clicked. This is a kind of contrived example, but oh well. So first off, you set this to true to say that we've handled the click and or touch event. And we're just going to sprite.set flip and sprite.get or is flip x, sprite.is flip y. Alright, so what this is going to do is whenever they click the background, it's going to flip on the x-axis, like so. Okay, so that's what happens when you click anywhere on the screen. Now you notice how that control gave it through. Now if I was to go back here to this input multiplexer, change the order, okay? Now look what happens. Flip, 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 flip. What's the problem? Our button is never getting called. Okay? So that's very critical. The order that the input is handled is very, it should be the order of priority that they should be received in. Okay, so only one last thing to really cover here, and this is something that we've been glossing over quite a bit in the past, is these return values, this true here. If there were further controls down the hierarchy, what this returning true says is you've been handled. So that means LibGDX now thinks, okay, this event has been handled and done. So if we actually wanted to pass it so that we had, say, stacks of, if we had, let's say, 2 or 3 sprites in the screen on the scene that overlapped each other, by handling this way, the very first one clicked is going to handle it, and then that event is dead. So if you want that event to continue propagating within the same input listener, you don't return true. So returning false basically says continue to propagate this event. So that is what these return values are ultimately doing. It's saying, yes, this event is handled. And if you want to continue processing the event, then you don't say yes there. So that's an important thing to cover. Not really specific to stage. It's specific to stage, but not specific to UI. But I'm not sure if I actually covered that in the past. So pretty much that's the extent of it, things I wanted to cover today. As you saw, the Scene UI controls are just like stage actors. You add them just like normal. They use the same event system, the same click listeners, etc. You can control them all. You can lay them all out by using a table layout. There's other layout options. There's a whole whack more controls than I've covered today. Like so far, I just used button and dialogue. But there are panels, there are scrolling, there are almost all the UI widgets you can think of for a normal operating system are available. The basic functionality is almost identical though, so there's not a lot of point in actually going into each different example. Just be aware that they do exist. There's a lot more than what I've shown today, but they work in the same manner. You create them just like you create an actor. You add them to a stage or you add them to a table, which you in turn add to the stage. And then if you want to multiplex stage UI, a scene UI, or a scene with normal rendering, you can do so. Just make sure in your draw call that whatever is topmost is drawn last, otherwise it'll overwrite. And then ditto for input. If you've got multiple input processors like we do with our stage and our application adapter here, you make use of an input multiplexer, and again, the order that you add things in is very important, because if it's in the opposite order like you just saw in that other example, the button never got called, and that was just a matter of switching these two back and forth. So you do want to make sure that they're in the right order when you call them. But that's the basics of it. It's a nice simple way to make fairly complex UIs that can be very resolution independent. Probably the biggest growing pain that you're going to encounter is creating that damn skin file. Like I said, if you go into the tests, there's one, the samples, there is one called UI skin in the GitHub repository for LibGDX that I think implements almost every control. It's very basic, but it will get you started. And so you can basically start customizing from there or adding your own versions from there. So you don't need to do this all from scratch, and you don't want to do it all from scratch because, as you saw in this demo, it's very error prone for typos. It's a pain in the ass, to be honest. So start from there and then tweak it to be your needs. The actual the naming conventions, etc., it's just mapping Java classes directly, or Java classes members directly to properties within the UI UI skin.json file. Again, that file name doesn't matter, but that seems to be the convention they've chosen. So that's about it for now, and that's about it for Scene2D. Unless there's something you specifically want to see covered, I'm going to move on to different topics next. Hope you enjoyed that. If you have any questions, of course, leave them below. I appreciate it. Thank you very much. Bye.